Okay, so now I'll do a quick walkthrough of how to draft a profile. So now I'll do a quick demonstration on how to go about drafting the profile. So again, want to see how much space we need on the graph paper horizontally and vertically. So we need a minimum of 280 feet horizontal and then a minimum of 7.2 feet between 515.5 and 522.7. So I rounded 7.2 up to 8 feet because, like I said earlier, it's always good to have a little extra space. And down here, I picked a 2 scale and a 20 scale horizontal. So we have exactly 14 1-inch grid blocks, and that's what we need along the bottom horizontal axis. And then we need a minimum of 4 1-inch grid blocks on the vertical axes. Coming down here, I selected a scale of 1 inch equals 20 horizontal and 1 inch equals 2 vertical. Go ahead over here, 20 and 2, 2, 1, 2, 20, 10 for the half inch, and 20 for the inch. Probably a little bit cleaner, more legible if I were to just enter this in on the PDF or with pen and paper. So now we will get to plotting our existing ground line. So at station 0 down here, we are at 522.7. So if 2 of these blocks equals 2 feet, again, we had 522.7, so we want to go up 7/10. That's 2/10, 4/10, 6/10, and 7 is going to be right there at 0, 0. And then out to 50, we have 522.4. 50 is right here. 522.4. Station 100, we got 520.1. Five 20.1, 125, 519.6. That's 19. 519, 19.2, 19.4, 19.6 at 125. And then at 150, we have 519.2 right there. 519.2 at 160. 519.1 at 180. We've got 519.1. At 200, we've got 518.1. And at 250, we have 516.5. And 515.5 at 280. $15.5 right in the middle. Then again, we'll go in and connect the dots. Showing our existing stream bed elevation and slope. All right. Now we can see where we have a nice flat section right here. Put that crossing in between 150 and 60. Right there, we want to go 2/10 below the stream bed elevation, which would put us right there. Bring this down 4/10 or 5 inches. 1, 2, 3, 4. Profile view of our slat. And another 3/10 of stone. And then referring back to the spreadsheet, our framestone size of R6, that is a D100, the largest diameter in a truckload of R6 should be about 24 inches. And to enter that in, so with a largest stone size of 2 feet, we want to ensure that that frame stone is going to be locked in. There's enough other riprap in that gradation that's going to help lock it in. And to do that, we don't want to just sit one 2 foot wide rock in the frame stone. We want a little extra. And that conversion is 1.5 times the largest frame stone. That's how wide and deep we want the frame stone trenches to be. So 1.5 times 2 is going to be 3. So we'll go down 3 feet for the frame stone. 1, 2, 3. And then 3 foot wide, which would be this is 10 feet. So we'll just check this. Three foot deep. As you can see here, it does appear to go up back to the existing stream channel elevation on a scale that is like we have here, 20 horizontal to 2 vertical. It's a very exaggerated scale. So this looks like we're coming back up a lot more than what it would look like in the field. However, it's a good thing to note at the pre-construction meeting that while yes, we want to have those slats or the bottom of the gravel or top of the gravel 2/10 below the stream bed elevation. Um, attention should be on making sure that this is blended in for positive drainage down the stream. If there's a little bit of ponding, it's to be expected on the slats or in the gravel, but um, just to point that out, and it's a good thing to point out to the contractor that we don't really want to create a pool here on the slats, although more often than not that will be the case until it eventually silts in and you've got one continuous grade going across from the frame stone upstream to the frame stone downstream. All right, so then we'll go in and I forgot my fabric. Indigo. Draw in our fabric. And add some labels. And just like that, we have our profile. And that concludes the stream crossing design spreadsheet and drafting tutorial. Any questions, please reach out to Kaket or HRG. Thank you.